Mars could have two moons, and there's evidence for it. We know that Mars has one moon called Phobos, and like Earth's moon, it's big compared to the planet's size, but we only know about Phobos because it passes between us and Mars. There might be another moon out there that is too far away to see. Hi, it's me, and this is my channel. You can tell that I'm holding a boom mic right now because I am recording an audio track for this video. It's different than usual. Today I want to talk about a paper published in the journal Nature Astronomy about a new way of looking at Mars and its orbit. This research says that Mars should have two moons instead of one, or at least it had two moons at some point in the past. Let's dive in. In our solar system, the moon is an outlier. Moons tend to be much smaller than their planets. Take Jupiter's moon, Europa, for instance. It's half the diameter of our moon and 2 times closer to Jupiter. So why does Mars have such a large moon? Scientists think it has to do with the way Phobos formed. It's likely that Phobos is a space rock that got captured by Mars's gravity long after the planet formed. In other words, it's a captured asteroid. Captured asteroids are pretty common in our solar system. We know that all the gas giants have rings of asteroids surrounding them, and those asteroids sometimes get knocked out of their orbit and crash into the planet. But there's also plenty of asteroids floating around between the orbits of Mars and Jupiter. These rocks could get too close to Mars and get captured by its gravity, just like Phobos did. To test this idea, scientists ran simulations trying to match Phobos's orbit around Mars. To do that, they used computer models of Mars and an asteroid. They found that in order for a second moon to exist, it would have to be 50 times more massive than Phobos. That's the mass of something like 200 million cars. Such a large moon would require a lot of energy to put it in its orbit. But scientists said it was possible that Mars could have had a bunch of giant volcanoes that were spewing lots of lava around when the planet was young. All that lava would have created a lot of heat and could have given Mars enough energy to support a second moon. But here's the problem with the story. Over time, the energy from Mars's volcanoes would have dissipated and the second moon would have fallen into the planet or been flung out into space. The researchers calculated that if Mars had a second moon like that, it would have happened about 4 billion years ago. If that's true, where is the moon now? Well, the answer to that question depends on how Mars lost its second moon. If it fell into the planet, then Mars would have become a little bit bigger and a little bit more massive. But based on what scientists know about geology, they don't think that a second moon crashing into Mars could have changed its mass by more than 0.002%. The mass of the stuff on Mars's surface is only 1% of its total mass, so this change would be pretty hard to detect. So according to these models, the moon falling into Mars doesn't explain why the planet hasn't changed more. On the other hand, if the second moon was flung out into space, it could be floating around somewhere in our solar system. Other moons in the solar system have been detected by seeing how they pass in front of their planets. But we can't do that with Mars, because we already know what's going on around it. Also, we can't look backwards in time to see if a second moon really existed. So the research team came up with another solution. They wanted to find out whether or not there was any evidence for a second moon in Mars's orbit today. They did this by studying Martian meteorites. Meteorites are rocks that blasted off the surface of Mars and landed on Earth. Scientists know that Mars has been losing its atmosphere over time. That's why today it's a dry, dusty desert instead of a warm, wet planet with lots of life. But the rate at which Mars loses its atmosphere tells us how fast its gravity is changing. The thing is, if Mars once had two moons, the gravitational pull of both moons would have been pulling on Mars's atmosphere, and that means the atmospheric loss rate would have been different than it is today. So the research team looked at Martian meteorites to see if they could detect a change in the atmospheric loss rate. They found that there was a change, but it happened about 1 billion years ago, much more recently than the models predict. So while this research doesn't settle the question of whether Mars has or ever had two moons, it does say that we need to rethink the story of how Phobos got there. Maybe it isn't a captured asteroid at all. Maybe it's just one half of a broken moon. Here on Earth, we often learn that moons form in pairs. Sometimes they even come in threes. It seems like Mars might have been part of that trend. But remember, Mars isn't the only rocky planet with a large moon. Venus and Earth both have big moons compared to their sizes. It's possible that all of the rocky planets started out with 2 moons, but we know that Earth and Venus don't have any moons. So maybe, just maybe, the same thing happened to Mars. We won't know for sure until we send people to Mars and search for signs of a second moon. It will take several years to get there, even with one of those flashy new space rockets. So let's hope that people are still interested in Mars by then. Thanks for watching this SCI Show video. If you think it's cool that we can learn about distant planets like Mars, then you might like the SCI Show Space podcast. Every week, the SCI Show Space podcast takes you into the greatest unknown regions of the universe, from black holes to wormholes and beyond. And we always bring along some fun space facts to help you navigate the solar system. You can listen to the podcast on your favorite podcast app. Just search for SCI Show Space, or you can listen right here. Thanks for listening, and thanks for watching.